In this group class, you'll learn all about how to sketch sine and cos. Enjoy! It's all about how we do sketching circular functions. So, has anyone seen anything to do with sketching circular functions before? Just to make sure how fast or how slow I should go through this. I'll take the... Oh, here we go. Heard it before, Nishal?
No, I actually haven't.
That's okay. So I'll make it as introductory as I can. So as far as the circular functions, so circular functions you can think of as wave-like patterns. In the screen share, what you're seeing is the graph of sine x. Now you guys might have seen this before when it comes to trig ratios, right? Sine, cos, and tan, that sort of thing. You can actually graph those, and the graph of what at least sine x looks like will look like this. It is a wave-like pattern. It repeats its pattern every so often. So a couple of basics to understand. The first is that on your x-axis is the angle of the circular function. Normally when you're dealing with trig ratios, you have like an angle in the brackets, whether it's 90 degrees or whether it's in radians even. In fact, what we look at a lot is when your circular function is in terms of radians. So the x-axis is all about the angle of the circular function. The y-axis is the value of your circular function at that spot. So you might know from earlier that different values of your angle will give you different exact values for a circular function. For example, sine of 90 degrees would mean it's pointing directly up, and so you're going to have a value of 1. In terms of radians, that would be pi over 2, this spot here. Quick question. Does everyone know how pi is involved in circular function stuff? Or is this a new letter to someone?
It's mostly just that in radians, pi is 180 degrees, right?
Correct. Yeah, precisely. Okay, good to know we're familiar with radians. Yeah, so the majority of math methods from year 11 and year 12 is going to be done in terms of radians. Only a select few circumstances will have degrees involved. But okay, that's that. What you'll find is that the circular functions will oscillate between a peak and a trough, which just means this spot up here or this spot down here. Absolute maximum, absolute minimum of your circular function. The generic sign, without any transformations attached to it, will go between +1 and -1 for its y values. For sine, specifically, it will start at the origin, go towards a peak, then middle, trough, middle, and continue that pattern over and over again. So you can see if you started here, it would be middle, peak, middle, trough, middle, peak, middle, trough, middle, peak, so on and so forth. You would typically start these at the origin, at x equals 0. And what you'll find is that the pattern will repeat in a fixed width. In the case of sine, it repeats every 2 pi. And we'll talk a bit about how to figure out when your circular function repeats in a bit. That's the basics of sine so far. So if anyone has any questions, either maybe raise your hand or pop something in the chat. I'm more than happy to address anything. As for cosine, basically looks the same, right? If you're not familiar with what these graphs look like, you might be looking at these and think, well, okay, one's red, one's green. It's actually a little bit different, right? So you can notice at this spot here, there's nothing. At this spot here, there's something. The graph of cosine is just slightly offset from what sine would look like. Cosine will always start at a peak instead of at the middle, but otherwise the pattern maintains, right? Peak, the next thing should be a middle, next thing should be a trough. Middle, peak, middle, trough, middle, peak, middle, trough. It's just where you start that's a little bit different. Everything else about the graph is the same. Still peaks and troughs at +/-1, and still repeats every 2 pi. Okay, there are dilation factors. So just like any other graph has like multiplications applied to it, like in this case, 3 sine of x, the way dilation factors work when they're applied at the front of your function means they are stretching it vertically. So what that means is instead of going between plus and -1, you're now multiplying those values to become plus and -3 instead. And that's pretty much all the a term is doing right there. So this term right at the front. N is a dilation factor that is affected directly on the x variable itself. And what that does is it stretches it horizontally. This term is what is responsible for showing you how long it'll take for the circular function to repeat once. Previously, a circular function would repeat in 2 pi because 2 pi is a full 360 degrees. When you have a 2 multiplying your x, suddenly it's half the length. Now you can see one full cycle is repeating in pi instead of 2 pi. So the main takeaways of the dilation factors is that they stretch vertically and horizontally. What you'll find is that the a value, so the value at the front of the circular function, if we go like all the way to the beginning, it's this thing here, the a, that's sort of informally known as the amplitude. It's not strictly the amplitude though. By definition, the amplitude is the distance between the mid-level and the peak of your circular function, whatever that happens to be. So if you pick any middle and any peak, it's whatever that distance is. And as such, that means it has to be positive no matter what, because it doesn't matter where you pick this from, you're always doing it with reference to the middle and the peak. The reason why I'm saying that the a term isn't necessarily the amplitude is because if I start drawing something now on the handwritten notes, if I had -3 sine x, you would not say that your amplitude is -3. Your amplitude is still 3. The negative sign is a reflection term. It works just a little bit differently to everything else. Any questions about the difference between amplitude and the actual a value itself? The next term worth considering would be the n value. So if we go back to what the generic circular function looks like, that's this thing in here, the dilation factor on the x term. That is responsible for calculating this quantity called the period of the circular function, which is what I was referring to earlier as how long it takes for the circular function to repeat once. The period of any circular function is given by this calculation here. Capital T, the period, is equal to 2 pi divided by n, your dilation factor, which is why when you look at cos 2x, in this case, n is 2. And so when you do 2 pi divided by 2, that gives you pi, which is why this repeats every pi. If we go back a bit more, if we look at sine x, or in this case 3 sine x, there's an implicit n equals 1 as your coefficient on this. And so when you do 2 pi divided by 1, that gives you 2 pi. And so the pattern repeats within 2 pi. Those are the very basics of sketching circular functions. Those are the main things that get moved around as far as questions will change things.
I just had a question for the period.
Yep.
So you know how you showed us the sine graph and you use the equation
Yep.
2 pi over n.
Mhm.
So is the n value, does it have to be a constant before the x, or can it be outside, like can it be 3 sine x?
It can be 3 sine x, but the n value is always whatever's attached here on the x.
Okay.
So if we look at where it is, that would be an a value out the front here. The n is whatever's in the brackets of the sign multiplying your x.
Okay.
So we can have a look at an example of how you might sketch. Oh, sorry. Before that, there's one more dot point I haven't mentioned, which is the so-called key features. So to me, when I say key features, I mean peaks, I mean the troughs, and I mean the mid-levels. These will always appear at quarter period interval between each other. So if you look at, for example, here 0 to pi, what you'll find is that midway between that, pi over 2, will be one of the key features, in this case a trough. Midway between pi over 2 and 0, so pi over 4, will be another key feature, in this case the middle. And then lastly, the other key feature is going to be midway between these two spots as well. So what you'll find is that when you're sketching these by hand, you're going to be basically dotting out peaks, troughs, and mid-levels, and then just drawing a curve to join all those key features together. And we'll see an example of what that looks like right here. So we're sketching the graph of 2 cos 3x for one cycle. One cycle just meaning one period. essentially. We use a framework something like this to make sure that we hit all the things that we need to for sketching the circular function. First up, nice and easy, just find the period. The end term is going to be this 3 value because it's the thing that's multiplying the x, and so the period is therefore going to be 2 pi divided by 3. Nice and simple. So for our circular function, we know we're going to start at 0 and then end at 2 pi on 3. So I do a quick peek, you can see it's going to end at 2 pi over 3 here and start at 0. From there, the next easiest thing would be to figure out where the peak and trough values are. And that's always going to occur from the a value, right? So normally it's plus minus 1. Because we have a 2 here, it's now going to be plus minus 2. So when we think about where our peaks and troughs are going to occur, peaks are at 2, troughs are at negative 2. From there, we know our y values, and we know some of our x values. We know where it starts and where it ends as far as x is concerned, but we don't know where all the other key features are. Like where do the peaks and troughs occur? Where do the mid-levels occur? That's what step 3 is all about. We're going to divide the period into 5 equal x coordinates. The easiest way to do that, by far, is you just look at the interval you have. In this case, it's from 0 to 2 pi over 3. Halve it. So you go from 2 pi over 3 to pi over 3. So instead of doing from 0 to 2 pi over 3, you've now got this tick that is pi over 3. Next thing you do, halve it again. That's going to give you the pi over 6 spot. So currently, you would have this, 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 and this. The only thing left to do is backfill here. So you can do that by, once you get here, what you end up doing is you basically add this pi over 6 to this pi over 3, giving you the pi over 2. That's one way of doing it. Or you just use your midpoint calculation to figure out the middle of these spots. Basically, all of these are pi over 6 separated from each other. 0 plus pi over 6 gives you pi over 6, plus another pi over 6 gets you to here, plus another gets you to here, plus another gets you to here. We do that because we've now outlined all the possible x values that are attributed to our peaks, troughs, and mid-levels. So once we have that, step 4 is figure out what are the y values at those spots. You can do that in a couple of ways. One way is to just memorize what cos looks like, recalling that the generic cos will start at a peak. Or the other thing you could do is literally sub in your values. So what is cos of 0? What is cos of pi over 6? Anyone have any trouble subbing in values like this into circular functions?
I didn't fully understand the way we substitute. I think I misunderstood it.
The way, so like if I said to do cos pi over 6, that's the bit that's tough?
No, it was more so like we had instead of it being 1, we've now put the crest at 2, and the crest and troughs at 2. So I've just gotten a bit confused on where we've gone from how we got 2 and pi by 6.
Yeah, okay. So the 2's, they came from the amplitude. So this a value at the front here, that's what was deciding how tall and how low we go on the circular function. So because there's a 2 there, our y value is going to be plus minus 2 as far as peak and trough. If I go back to a previous example we've had, here is sine x, which is a peak of 1 and a trough of negative 1, because there's a 1 out the front here. And here is 3 sine x. We now have a peak of 3 and a trough of negative 3. So the basic rule is, whatever this number is, slap a plus minus out the front of it, and that becomes your peaks and troughs. That bit's clear?
Yes, that makes sense.
Okay. And then as for how we got these little intervals here, that came from the period. The whole point here is to figure out where do those peaks and troughs and mid-levels occur. So we know from our period that it's going to be from 0 to 2 pi over 3. The other thing we know is that each key feature is equally separated along that interval. So if we look, if we just sort of take a peek at the very end, you'll notice that the peak will start at 0 because it's cos. The next thing will be a quarter of the period through. The next thing will be half a period through. The next thing will be 3/4 through. and the final thing will be 4/4 through. So what we're trying to do here is take our value of the period, which is 2 pi over 3, and then just split it 4 ways to figure out where those dots are going to go. So we've just taken our 2 pi over 3, halved it to pi over 3, halved it again to pi over 6, and you've effectively quartered your interval. Is that cool?
Yeah, that makes sense actually.
Okay. So that's where we're at currently. We have all our x values and we know the y values. All we're going to do now is decide or look at, do we have cos or do we have sine? In this case, we have cos, and either memorize that cos starts at a peak or just sub in cos of 0 and then figure out that cos is in fact 1 at that spot. So we start at the peak, as we suggested. A peak is 2, which is why we're going to give y equals 2 at that spot of x equals 0. And then we just go in order with the rest of the pattern. So from a peak, it can't go any higher. The next thing that it has to go down to is the middle. Then it has to go down even further to trough, mid-peak, trough, mid-peak, trough, and you continue that as many times as you need to. In this case, we're only asked to do one cycle, which means start at peak, end at peak. So how you do this by hand is you would literally draw these little dots out, hopefully not in red pen, maybe just in grey lead so you can rub it out. And then you just draw the curve connecting everything. So you just draw a nice little wave going through everything. Any questions about that?
So for in the future, will it say state the restrictions on the angle on the circular function, or like will it say like sketch it with a restriction?
Yep. Yeah, it will. So sometimes it'll say sketch 1 cycle. Sometimes it'll give you the domain. Like in this case, it's between 0 and 2 pi over 3. If we see some like typical examples, let's see. It'll say sketch between 0 and 1, sketch between 0 and pi, negative pi and 2 pi. They give you a domain, or I would just say cycle.
Okay.
Yeah, that's that. Okay, so those are the basics when you've just got different a terms and different n terms. That's just stretching it vertically and stretching it horizontally. The next thing that could possibly happen is when you have a reflection on your circular function. These work exactly the same as it would for any other type of function. When your negative sign is out the front of the function, that's a reflection in the x. So the x-axis is the mirror, and so instead of sine being all the way up here, it's now going to drop down here. Right? So if we compare, it's a bit hard to compare the two. Maybe I'll get my calculator to show you both. So this will be on the document camera instead. If I have sine of x, it normally looks like this. And then if I were to put a negative sign on there, keep in mind I'll even have like a pencil there to show where it was before. If I then hit enter on that, you'll see it's flipped. So the x-axis acts like the mirror. Peaks become troughs is really the only thing you have to worry about there. Easiest way to think about it, all peaks become troughs, all troughs become peaks. Okay, so back to the pre-written notes. Fundamentally, we don't really change what we do here when we have a reflection. It just means that when you're dotting out all those spots where you would normally put a peak, you put a trough, and vice versa. So negative sign looks like this, negative cos looks like this. Any questions about reflections? Okay, next up, because reflections are kind of nothing too crazy, you don't really have to change what you're doing a whole lot. The next thing we bundle into this is horizontal translations. So horizontal translations, again, work very similar to what you're expecting when it comes to like quadratics, for example, where you'd have your turning point form, you'd have like an x minus h. When you had a minus, it would shift right. When you had a plus, it would shift left. That's really all we're doing here. So when you have x minus pi over 2 in your sign, instead of it starting at 0, we're now starting at pi over 2 instead. It's shifted right by pi over 2. That also means we're not stopping at 2 pi anymore. We're also taking the, we're now taking the upper bound that was 2 pi, and we're shifting it pi over 2 forward. In the case of cos, I've given you a backwards translation. So plus pi over 3 means we're shifting left by pi over 3. So it starts at a peak always, unless there's any reflections. And because we're shifting left pi over 3, the peak is now occurring at x equals negative pi over 3. And this 5 pi over 3 here is just 2 pi after you've subtracted pi over 3 from it. Okay. As for how we draw these by hand, there's only a little bit different here. We're still hitting a lot of key things here, like the period, the peak and trough, splitting it into 5 equal coordinates, y values, all these things are fairly trivial. We've done them, well, not trivial, we've done them before. The only thing that's going to matter now is because we have this horizontal translation, we're going to take this 5 equal x coordinates thing and then just shift them all forward or back by how much we need to. So here's an example of when you're given a specific domain to work with. In this case, we're doing it 3 sine of x take pi over 2, and we're doing it from pi over 2 to 5 pi over 2 now. So some of the same steps that we've looked at before. Period is 2 pi over n. In this case, you can look at the coefficient on the x. You can see that it's 1, hence the period is going to be 2 pi. From there, peaks and troughs. So whatever this is, slap a plus minus out the front of it. So peak is going to be at 3, trough is going to be at negative 3. Divide into 5 equal x coordinates. Again, that's just half and half again. 2 pi becomes pi becomes pi over 2, and then you just backfill this last spot in here. Now the thing that's a little bit different here is now, because we have this shift right of pi over 2, we're going to take all of these values and shift them right by pi over 2. So the good news is they're already separated by pi over 2 as is. So if I were to move this to the right by pi over 2, it does just become pi. And so the question you'll find is usually nice enough to do that for you, where the interval that you've created, you pretty much just take whatever the last one is and then just chuck it at the end. Is it clear enough how we go from here to here? This is usually a bit of a tough one, so if we have any questions, feel free to reach out. But once we have our new interval, we treat everything like we have before. So we have sine in this case, and so sine will always start at the middle. We're shifting everything right by pi over 2, so our new starting spot is pi over 2, and it's going to be a middle. Because we have positive sine, it'll go to a peak next. So either memorize that or just sub in what is sine of pi minus pi over 2. You could solve that if you wanted to, and that will tell you whether it's a 3 or a negative 3. And then, yeah, you just fill out the rest of the dots. Middle, peak, middle, trough. Middle, peak, middle, trough. And draw the curve. So the reason why I've mentioned specifically to find the y-intercept here is because when you have a horizontal translation, it's likely that your y-intercept won't be one of your key features anymore, as in peak, trough, and mid. If we do a very brief, well, here we don't even have one because it's not part of the domain, but if we do a quick squeeze of what we had before, you can see that like this y-intercept, it's not a middle, it's not a peak, it's not a trough. We haven't already found it, and so you might have to do an additional step to figure out what that is most of the time. So pi over 3 did it, pi over 2 didn't because it was going forward. Versus if you had it like previously, you can see it starts at 0, and so you don't have to additionally solve for it. Whereas with horizontal translations, you might have to. And yeah, that gives you that. Fair enough. Starting to get a bit harder now. So
I had just a question.
Mhm.
So how do we find that y-intercept? So
so it's the same way for any other or any other function in general. Y-intercept is always x equals 0. So if your domain did stretch out to hit x equals 0, or anything beyond that, anything that will cause you to have a y-intercept, you just sub in your x equals 0. So in this case, we would have, let's see, what do we actually have? So if I go to the handwritten bit now and just sort of write out the rest of the equation, it was positive 3. Positive 3 sine of x minus pi over 2. And so if you want to find, because this is a function, if you want to find where the y-intercept is, you sub in x equals 0. So that's going to mean you now have 3 sine of 0 minus pi over 2. That's going to give you 3 sine of minus pi on 2. And then this is where you have to know your exact values. Anyone have any trouble with solving these?
I just had a quick question about still finding the period. So
Mhm.
you said it's 2 pi by n, and so then because we took n as the coefficient of x, and so in a previous example, I think you took n as like n of sine x, I believe, like 3 sine x. And so yeah, like 2 cos into 3x. And so oh, okay, then I think I misunderstood.
Yeah. So it's never this value at the front. You're probably thinking of the 3 sine x one.
Yeah,
It's always whatever's on the x. Yeah.
right then.
Cool. But as for this one that we just had, we're just doing here, does anyone know what sine of negative pi over 2 is?
Would it just be, I'm just guessing 0.5, negative 0.5?
Not quite. So for these circular functions that you solve, you have to use the unit circle. So if we bust open a unit circle, just one that's already pre-done, let's see. So let's see. Does any of this look familiar to anyone? On the screen share?
Yeah.
Okay, that's good. So very briefly, the way this works is if you want to evaluate sine of a particular angle, it means you want to locate that angle on your unit circle and then give the y value at that spot. Now, negative pi over 2, you might notice, doesn't actually appear on this, at least not formally, it's not labeled. So the way we handle negative angles is basically instead of counting, so this one counts in an anti-clockwise motion, so pi over 6, and it gets bigger and bigger as you go anti-clockwise. For negatives, you're effectively just going backwards instead. So what we'll find is negative pi over 2 is this spot vertically down, and the coordinate at that spot is 0, negative 1. We're doing sine, and so we want the y value at this spot. So sine of negative pi over 2 will therefore be negative 1. Keep in mind, however, we have 3 times sine of negative pi over 2. So that negative 1 is now going to become negative 3. And so our y-intercept we would expect for this graph would be y equals negative 3, which makes a deal of sense because if you think about the peaks and troughs here, if you were to go back an additional pi over 2, that would be another quarter period. And so if you think about how the pattern would work backwards, it would be middle, trough, middle, peak, middle, trough. So you've hit that negative 3 again. Cool?
Yeah.
Might not always happen that way. Sometimes you'll get like a more complicated thing. Like you might have to use any of these angles, which aren't any different really, but might be slightly more complicated. But okay, that's what happens when you have horizontal translations. This is usually where the book will stop and then give a whole bunch of examples to practice on. I think just for the sake of making sure we get it all in the same session, we'll look at how we handle vertical translations as well. Just keeping in mind that when you get to this, you'll probably be doing these in individual sections. Okay, so we've looked at how to handle amplitude, period, horizontal translations, that sort of stuff. When you add vertical translations to the mix, this is where it gets really painful because vertical translations can mean a lot of different things. For one, it could mean that you never touch the x-axis, in which case you're actually lucky because that means you don't have to solve anything really. But in other cases, it might mean that your x-intercepts will no longer occur at those key features. So you have to solve those individually. That's the painful bit of it. But fundamentally, vertical translations work the same as they have for any other function. If you have a plus or minus out the front of the entire function, then that is a vertical either up or a vertical down. Vertical up just means a plus, in which case you see this, and a down would mean a minus, in which case you would see something like this. Now, the way it works for circular functions specifically is you can think of it as setting your new mid-level. So if you think about how this circular function now looks, instead of going between with 0 as the middle, we now have 2 as the middle because we've been shifted up by 2. And once again, because it's sine, instead of going plus minus 1, now because the new middle is 2, you go plus minus 1 from 2. So you go up 1 to 3, and you go down 1 to 1. Is that clear so far? This is where things get a lot more complicated.
So just by having like just a +2 or -2, it just means that it's up or down. That just amount doesn't really change much.
As far as what the graph looks like, it doesn't change much. As far as what you have to now solve, it makes it more complicated. The things that you have to do to solve it. But as you're looking at the graph, yeah, this doesn't look too bad currently. We'll see an example of why it becomes more complicated. But yes, when you have a vertical translation, it just means shift everything up by 2.
Just had a question. So you know the question we saw before this? So the one that you said we had to know our values if
Yep.
it intercepted the x.
Mhm.
Would that be a question on like paper 1 without calculator and bound reference?
Yep. So one of the things you guys will have to do is know this off by heart. It looks like a lot. It's less than you think, but still, how to put it? It's less than you think, but still a decent amount of effort to memorize it. I detail a way of memorizing it in my notes here to minimize the amount of effort that you have to put into memorizing things. I'll very briefly talk about how you would do that. The way you would probably do that is you would look just at a single quadrant of angles, and as long as you're able to memorize pi over 6, pi over 4, pi over 3, then all you end up doing is flipping those spots across different quadrants. It's a bit out of the scope of this lesson to cover this. I do have written and recorded lecture content covering that sort of stuff. Let's see, where is it exactly? So you could look at the unit circle document, which is document 2 of circular functions. You could look at, I think document 3 has it. Yeah, document 3 talks about how to, no, that just talks about how to use it. More so document 4. Maybe it is all document 2. Let's go back a bit. Oh, it is 2, yeah. Everything you need to know about it is here. So as long as you can know this table, then fundamentally all you're really doing is flipping things around. So have a read and a watch of those in the classroom. That'd be my recommendation for that. But okay, that's that. Let's get rid of some of these. Cool. Okay, vertical translations. So what do we have to do to now account for vertical translations? Well, you'll notice again, a lot of the things are the same. Find the period, doesn't change. Peak and troughs, slightly different now. So instead of just doing plus or minus a, you now have to add whatever your vertical translation is. So this one's shifted up by 1. And so now you're doing plus minus 2, but you're adding 1 to both of those. So starting at 2, adding 1 gets you to 3. Starting at 1, Starting at 1 and adding 2 gets you to 3. And then subtracting 2 gets you to -1. Step 3 doesn't actually change, right? That whole step 3 and 4, that's exactly as we've talked about before, which is divide it into 5 and then shift it according to the horizontal translation. Step 5 is again just dotting out those key features. And then step 6 is drawing the curve. So pretty much everything from here, except this little change here, is what you've already done just previously. Where it gets a bit more annoying is now it's likely that you'll have to find your x-intercepts individually. Previously they were key features, now they're not. But okay, we'll look at how that looks. So we have a cosine, it's got a vertical translation of 1. I've been nice and I've taken off the horizontal translation, so we don't have to worry about that too much. Period, 2 pi divided by n. In this case, n is 1, because the coefficient on the x is the 1. Peak and trough, 1, as I said before, 1 plus 2 gets you to 3, 1 minus 2 gets you to -1. Divide the period into 5 equal spots, so period was 2 pi, halve it to pi, halve it to pi over 2, fill in that remaining spot. We've seen this exact one before. And then you can see the peak there of 3, and I haven't quite labelled it, but the trough would be here at -1. Adjust if necessary. There is no horizontal translation this time, so you won't do that. In fact, what you'll find is, if I do a quick squiz and have a look at all the graphs here, even when they do look at, where is it? Yeah, when they start adding more complicated things, oh, they're doing it. They actually will. Interesting. Never mind. Only the hardest ones will have both a horizontal and a vertical. In fact, the only one, yeah, very few have both a horizontal and a vertical. So it is painful to do, which is why they're sparing with their use of it. But okay, anyway, back to where we were. So we've done any adjustments we need to, which is no adjustments. Find the y values. So we had a negative cos, which means instead of starting at the peak, we're going to flip that down to a trough. So it would have been up here at 3, now it's going to start at -1. But from there, has to go to a middle, then a peak, middle, trough, middle peak, middle trough, middle peak, middle trough. Draw the curve, and now what you'll see is this and this hasn't been solved yet. Unfortunately, for any function, for any function, the mandatory things are intercepts and endpoints. We have our endpoints, but we don't have all the intercepts necessary. So we have to now find those. When it comes to solving x-intercepts, it's the same as any other function. You sub in y equals 0. So in this case, our function is -2 cos x plus 1, and so we're going to sub in a y equals 0 onto that. From there, we just rearrange. So the only way you can solve a circular function is if you can get that circular function on its own, and then, an exact value on the other side. This is an entire lesson on its own. Does anyone have any trouble solving this sort of circular function?
It would just be the inverse of cos, right? And just put it on the other side.
Yeah, cos inverse of a half would be your would be an answer to that, yeah. But you do want to give the exact values, which are pi over 3 and 5 pi over 3. Do you know where these come from?
Yeah, so these are just so just for this is by hand, or would this be like a calculator thing?
By hand. Yeah.
Okay.
Yeah, so the way this works, just very briefly, again, you can read up on, that would be, I think it was document 4, right? Yeah. So if you want to read up on exactly how you solve those, then this is where you would do it, module 4 of the circular function spot. It shows you everything you need to know. Very briefly, how it works is, once you have an equation like this, what you have is an unknown angle, but a known value. So just like we talked about with the unit circle before, how you would first look at the angle and then give the value, we're just going to do the opposite of that. Because we know the value, we don't know the angle. Cos equals a half. When it comes to unit circle, cos is the x value. So it's all of these x coordinates here, cos. If we're told that cos is equal to a half, we just need to find where on the unit circle is x equal to a half. And that's going to be these spots here that I've highlighted. One is at pi over 3, the other is at 5 pi over 3. That's where these came from. So you would ideally have this memorized. We'll get there. It takes some time. That's where these came from. And so those become the solutions to your circular function, right? You subbed in y equals 0. The solutions of that should have been and are the x-intercepts. I get that's probably a bit on the tougher side. That is the... Well, actually, this is about as far as this goes, so is that fair enough how these came from? I can dive into more detail how you solve these if you like. Okay, no worries then.
Could you just repeat that? Sorry.
Repeat my question or repeat
Yeah,
where this
your
came from?
question.
Yeah, I was asking if anyone wanted me to dive any deeper into how or where these came from.
Oh no, that's all good.
That's good. Okay, sweet. All right. So that's the graphs of sine and cos. Pretty much a full information overload there. We could look at tan. It's probably a bit early to do that. Yeah, we'll just leave that there. Okay. So let's do some basic sine and cos together, and I'll pick some examples from the book. We'll sketch it together. In fact, what I'll do is I'll grab some of the summaries. I'll put that in the chat so we can see how we can at least follow the same sort of procedure. So I'm going to do a screenshot of the steps that we follow. We're just going to take it all the way back to the basics, do a few of those, and then work our way up for the remainder of the time we have. Okay, so 6D is a decent place to start here. Geez, they're going to give you some... Where's a decent one? It doesn't say to sketch it, we're going to sketch it anyway. So we're going to start with 2A here. Now, there's nothing to really read this, so what I'm going to do is just write it on the handwritten notes anyway, and then we'll just do it together from the handwritten notes only. Y equals 4 sine 3x. Okay, so I've given everyone a screenshot of the steps we have to follow. I'll even have them on the screen share as well. What's the first thing we should do when it comes to sketching this graph?
Find the period.
Find the period, yeah. And so how do we grab that?
2 pi over n.
Yep. Capital T equals 2 pi over n. And so what must our period be?
2 pi over 3.
2 pi over 3, yep. Nice. All right, that's period. Where do we go from here?
Find the peak and trough through magnitudes.
So what are they going to be?
They should be...
Yeah,
Is
jump
it
in.
just 3?
So 3 is the n value. When it comes to peak and troughs, you're looking for the a, which is over here instead.
Plus or minus 4.
Plus minus 4, yeah. So going to have peak of 4, trough, OUGH of 4. Net minus 4 rather. All right, where do we go from here?
Divide the period.
Yep, divide it up. Cool. So we're going to start like this. I'm just going to pretend that it's from it's one cycle. So we didn't actually have a domain on this because I kind of just picked a random question to do. So how do we label out these x values?
So start at 0.
Yep, start at 0.
And we would get the period, and then we'd plot that as a maximum.
Yep, as a maximum. That's good. 2 pi over 3.
And just divide that, right?
Yep, that's good. Yeah, split it in half again. So what's that going to look like?
So I just had a question. Just to like divide 2 pi over 3 in half.
Yep.
What would be like the quickest and simplest way to just like memorize that, or just like no?
What's half of 2 pi over 3? How to memorize this division?
Yeah.
Yeah, just knock off the 2. So whenever you divide anything by 2, you can either double the denominator or halve the numerator. And in this case, halving the numerator is a lot easier. So it's like saying I've got 2 pi's over 3, right? 2a divided by 2 gets you back to a, or a is just pi over 3. So halving, you have 2 of one thing, now you have 1 of that thing.
Okay.
So it becomes pi over 3. So that's using the divide the numerator in 2 approach. If you then halve that again, probably can't divide the numerator in 2 because you don't want to have a fraction on your numerator. So the next best bet is doubling the denominator, which gives you
Pi on 6.
pi on 6. Yeah. Now here's the slightly trickier bit. You've got to backfill this spot here. Anyone remember how to do that?
Just adding pi on 6.
So what do we have as a final answer then? I think Nishal wanted to have a go there.
Yeah, I was gonna say like 2 pi on 6 plus pi, so 3 pi on 3. So
Yep.
pi on 2.
Pi on 2. There you go. Nice. Nice and collaborative. Awesome. All right, that's step 3 all done. Step 4, what are we doing? Bit tougher now because now you got to, if you haven't seen the graphs before, it might be a bit tough to memorize what their shapes look like. What I'll do is I'll, on the main screen, show you the generic sine and cos. Oh, bit hard. Is that too small to look at on the screen share? Maybe I'll just do some photos of both of them and you can see it in the chat one at a time. Fine. That's cos, and then you can use that to inform where we should start and where we should end.
So you just start at 0 for a sine?
Yep, sine starts at 0. Nice. So that's 1 dot there. Where do we go next? Bit tougher, is it?
Is it like middle, peak, trough?
Yeah, middle peak trough. Yeah, middle peak trough, over and over again. Nice. So what do those coordinates then become?
Since it's middle peak trough, you start at 0 and then pi at pi by 3 it becomes. Oh, sorry, no. At pi by 6 it should be a peak, and then at pi by 3. Yeah, pi by 3 should be middle, and then pi by 2 it should be trough.
Mhm.
And then 2 pi by 3 is middle again.
Perfect. Yeah, exactly. Middle peak trough, middle peak. Yeah. Hang on, did I say that wrong? Middle peak trough. Middle peak, middle trough. Yeah, that's what I was saying wrong. Probably. And then, yeah, just draw the line connecting everything. That is sketching circular functions when you only have a and n to worry about. So we've done that one together. Any lingering questions on what's going on there? Okay. That's a bulk of that. Let's see. Wow, they really don't give that many. Oh, right, because it's I do it in a different chapter. Okay, let's find another one. So I'll take a stab at. You know what? Let's knock off the n for now. We'll just make up our own one. This time we'll do a horizontal translation one. So back to the handwritten notes. We're just going to have 3. What do we have? So we had sine before. Let's do cos this time. Cos of x, and then we'll call it minus pi over 4. No, we'll do plus pi over 2, because we did a minus pi over 2 before. Now we'll do a plus pi over 2. Okay, y equals that. And then as for the steps that you should follow, it's only slightly revised from before. You're just going to be slightly adjusting the x domain. So once again, you have a screenshot of that should you wish to follow it in the chat, or you could have a look at it on the screen share. All right, how do we start?
Period again.
Period. Yep. What's the period for this one?
It's just 2 pi.
2 pi, since n is 1. And so you're going to have period equals 2 pi divided by 1, which of course is just 2 pi. Nice. All right, where do we go from there?
Find the peaks and troughs, which is just it's just 3,
Yep.
or plus or minus 3.
Plus minus 3, yeah. So I'll call it p slash t can be plus minus 3. Cool. What else have we got?
Divide the period into 5 equal coordinates.
Yep. Divide that one up. So let's draw this a bit lower than this random. In fact, let's erase it. Let's get rid of that. Okay. Let's see. So we'll draw our axes. How do we do that?
So the whole period is 2 pi, so you just do 2 pi by 5, I believe.
Yeah, so you are splitting it into 5 equal parts. The thing to watch out for is that 0 is considered one of those parts. And so you actually end up dividing it by 4 because 0 counts as one of the sections. A little bit weird, but yeah.
So then it becomes, what, 0 pi by 2 pi, 3 2 pi 3 pi by 2 and 2 pi.
Exactly right. That's our starting 5 spots. So you can see this is equally spaced in 5 different spots, even though you've divided by 4. Bit strange, but that's how it came out to be. Yeah, okay. So that's that was
In this case of dividing into 5 equal segments, including 0, do we never work with the negative axis? Because that's what I've been seeing when we've been drawing out the graphs. Even though we do have access to negative pi and negative 2 pi, it never seems that we actually use it.
Well, you'll see that very soon. If you have a look at the next step, have a look and see what you have to do here. This will answer your question. When you adjust, what do we have to adjust like?
You have to move it by pi by 2, I believe.
Yep. In what direction though? Left or right?
Left.
Left. Yeah. So all these spots are now going to be shifted pi over 2 backwards. So because these are already in intervals of pi over 2, a bit nicer, it just means that instead of having this final thing at 2 pi now, we're now going to have another spot here at negative pi over 2. So you can imagine starting at negative pi over 2, add pi over 2 to that, gets you to 0, another pi over 2, another pi over 2, a final pi over 2. And just like that, you've now crossed into the negative domain. Ideally, you'd want to stick in the positive domain just because it's easier to work with positive numbers, but sometimes your hand gets forced and you have to do it because your domain is negative. But all right, that is step 4 we've adjusted. Where do we go from here?
Find the y values.
Yep, find the y values. So in order of all these, what's it look like?
Would that just be so I don't need to get that.
So refer back to the graphs that you have as screenshots. Compare, because we're doing cos this time, so think about where cos normally starts. Think about our new starting location and then figure out where you'd put the dot.
It would be at the peak.
At the peak, yeah. Cos always starts at a peak unless there's a negative on it. And so the new starting point being at negative pi over 2 means that we now put a peak on that spot. Where do we go from here to fill out the rest of them?
Then we go to peak, so then we go to middle at 0.
Yep.
And then trough, and then middle peak.
Yep, precisely. Peak, middle, trough, middle, peak. So you'll find cos kind of looks like a U a bunch of times if you're drawing it slightly poorly. Ideally, you would round it off on those edges like that, rather than going up that way. But it can be a bit hard to. Yeah, think about like a rounded V, I suppose. But yeah, that will be how you draw one cycle of this circular function. The only thing you haven't really seen is normally these will come with a domain. They'll say x is an element of negative pi over 2 to 3 pi over 2. They'll tell you to do it for a specific thing. Because technically speaking, if you're only doing one cycle, you can choose where you put that cycle. It just makes things harder to make it anything. To do anything else than what we just did would make it slightly harder. But equally valid would be to say, all right, I don't want to do anything in the negative, so I'll cut off this quarter cycle. And what I'll instead do is add another quarter cycle in the positive, because that still gives you a net full cycle. All right, this is still middle peak, middle trough peak. Sorry, say again. Middle trough, middle peak, middle. This is still one full cycle, but just a different section of the graph. So if they don't specify a domain, you can technically do that, but my question would be, why bother? Because it just sort of makes it a bit weirder for you to handle. Because when you look at this, that just looks like a negative sign, right? Sign would normally go to a peak. It looks a little bit off when you draw that instead of what we did before. So, while technically valid, usually just stick to the way I've mentioned it. But this is actually pretty good. So considering this was like, I think what was Nishal's first time seeing graphing of circular functions, the fact that you stuck it out this far all the way to horizontal is pretty impressive, all things considered. Usually, like as you saw perhaps in the book, if you check the chapters, they usually teach that individually. 6D is just A and N terms. 6F is now horizontal translations, and then 6G is slap verticals onto that as well. So the fact that we've done that all in one class is impressive for you guys. I'm glad you were sticking along with it. Cool. That does bring us to end of class there. Any closing comments from anyone, or shall we wait till the next class? Easy. All right. As part of the program, you can ask me any questions directly. If you'd rather them wait till the Friday, then by all means submit them there and we can go through individual questions live. That Friday is a Q&A, so there is no agenda. So if there is something you want to go through live, that's the way to do it. All right. I'll let you guys enjoy the rest of your week up until Friday. Have a good one.